What's up guys, this is Tom with MotorGo Support. Today I'm going to show you how to build a balance bot. The first thing you're going to want to do is go to our printables and download all the project files and print them. But let's go ahead and print it and get started. Let's talk electronics. For this project, we used an NPU 6050 IMU, which is an affordable option on Amazon. How do I explain this? Well, we basically... The point is that when you duct tape this to a MotorGo and stick it in a balance bot, it gives you fast and accurate pitch readings that allow it to balance. I'm going to tell you a little bit about what makes this guy tick. If you were to stand him up and look at him from the side and put a force arrow pushing him backwards like that, you want to guess which way he would fall? Ding, 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 he falls back just like that. And if you were to put a forward force, he would fall the same way. There's also a slight difference between the IMU's 0 point and the robot's balance point, but let's ignore that for now and just call this concept balance. Now, if you look at him from the top, this robot has two wheels like any cool robot should. So if you apply a twist one way or the other, they'll turn that way. Problem is, we don't want our robot spinning around all willy-nilly, so we want him to resist that. Let's call this concept steering and say that we don't want him to steer unless we tell him to. The next one's going to be a little more abstract, so bear with me. Remember when I told you that the IMU 0 point and the balance point of the robot are a little different? Well, that actually turns out to be important because if you tell the software the wrong balance point, then what it's going to do is it's going to make the robot lean a little forward or a little back. So we need a controller to tell the motors over time to go to 0 velocity. Otherwise, when it leans forward, they'll just go and go and go. The other issue is when you have a balance controller that's really strong, it might create a lot of oscillations or vibrations in the system. So we want a term to act like a damper or a brake and slow down velocity, and that's what this velocity term is. So how do you actually do it? I thought you'd never ask. You start by calculating the individual control commands. To do that, call each controller as a function and put in the thing you want to control as the input. It's going to try and set that to 0. Next thing you do is combine those signals and send them to the motor. In this case, the MotorGo is using 3 PID controllers to decide what signal to send to each motor. If you study this graphic, you'll know everything you need to decide how to tune your PID controller. The way you tune your PID controllers is over Wi-Fi. When a computer really likes a MotorGo, it'll send a love letter asking the MotorGo to change one of its PID parameters, and then the MotorGo will respond and tell the computer that it did that, and that's how they fall in love. The neat thing is, you can do this with any configurable controller that you set up in the code. That's enough gossip out of you. We have a handy PID tuning web app that lets you interact with the MotorGo in real time, so we're going to use that for this project. You can see that if I turn on my balance controller and pick up the robot and tilt it, he'll try to correct by spinning his wheels in the direction that he's tilted. That's what we want. You can also see that when I turn on the steering controller, he'll bounce back to where he was facing if I try and turn him. I'm going to cheat because I already know about what parameters are going to work for this robot, so I'm going to set those and see how it works. If your eyes are half as good as mine, you'll see that this robot keeps leaning forward and running into stuff. Now, there's a velocity term that should help a little bit, but we need the balance point to be pretty accurate for this controller design to work. So instead of updating my code and reflashing it to the board every time I want to test a new balance point, I'm just going to make it a configurable object in the PID manager and blah, 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 blah. Basically, what I'm doing is creating another PID controller, but I'm not using it like a PID controller. I'm just taking the P value from that input and setting that equal to the balance point target for the balance controller. And now you can see I can tune the balance point and all 3 PID controllers that we need to make this balance bot work. It does this all over Wi-Fi, and as you can see, it's pretty quick. So I can test a bunch of different values just on my computer screen playing with it on my desk. That's all for this time. Please like and subscribe, it really helps the channel.